Hello, boys and girls. Mr. Giomini coming to you with a little brief intro slash review on measures of central tendency and spread for lesson 1-2 in our math curriculum. You guys may have remembered this from last year. It's called landmarks. Well, in sixth grade, we get a little bit more technical. We call measures of central tendency and spread. Measures of central tendency because typically those numbers, when we organize them and calculate them, or find those measures of central tendency, which would be the mean, median, and mode, those tend to fall in the middle of the data if I was putting order from least to greatest. The measure of spread, we take the maximum value and subtract from it the minimum value. And that's why we call it the range. Think about a range as a wide open flat land, very far apart from one point to the other. So that's why we have that large spread, so we call that the spread. Now what I've done is I've taken my first period chapter 1 pretest scores. So these are the students from my first period. These are the scores not listed in any certain order. I reorganize them from least to greatest to save some time. I've also, let's see here, I want to double check to make sure I have all the values. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. I should have 25 values down here as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. All right, good. Now, on the pretest, many of you did a great job with figuring out the range. And I'm going to start with that because that's typically the easiest one to calculate. So if I were to calculate the range for this set of data, obviously I take the maximum minus the minimum. I'll do that over here. So the largest value is 75, and I'll subtract from it the smallest value, and that would be 22. So my range for this set of data is 5 minus 2 is 3, 7 minus 2 is 5. So my range is 53. Now obviously we call that measure of spread instead of central tendency because if I were to put a 53 in this set of data, it'd be somewhere right in here. Well, that's not a good number to place. 53 is not a good number to have represent all the data. It's good if I was looking at maybe just these pieces of data right here, but I need to take consideration all these numbers. Okay, so let's take a look at let's go look at the measures of central tendency. And I think the one that's easiest to find is probably our mode. Now I see I have 1, 2, 3, 4 22s. I also have 1, 2, 3, 4 28s. I have 3 42, so that's gone. I don't need to worry about that. Now, I was in a stats class in college, and I was told that if there's 2 modes, there's really no mode. But I do know from previous math curriculums in 6th grade that they will say if there's 2 numbers that repeat the same amount of times that they have the data has 2 modes. So this would have one mode would be 22. The other mode would be 28. Okay. Now let's calculate the median, the number in the middle. Now I said I had 25. Now let's see here. If I take 1 away, that's 24. Split 24 in 2, we have 12. So I can actually eliminate 12 pieces of data from the top part or the bottom part and 12 pieces from the bottom. 12 and 12 is 24 plus that one that's in the middle by itself, that'd be 25. You guys are used to crossing out front to back. You can do that. I'm just trying to speed up the process. So if I take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces of data there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's cut off 12 pieces of data from the back side or from the higher extreme. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. I have 12 on this side, 12 on this side. The number that's left in the middle is 31, so my median is 31. Now, my mean, the average of all the data. Now, I did a little math before this, and I know that when I add all these together, I get a sum of 903. That is a large number, and we have to do some division with that 903. I'm going to divide it by how many pieces of data are in this data set, which is 25. Okay, now many of us are already probably sweating because we have to do long division. Oh my gosh. Now, what I like to do when I do some long division, I like to put a little multiplication sign here. Because I always think to myself, I'm going to multiply this divisor by the quotient to get as close as I can to the dividend. So 25 does not go into 9. Nothing times 25 will give me 9, at least a whole number. Now I go 25 times what gives me, now I'm going into 90. Well, I know 25 times 4 gives me 100. That's too big, so one less would be 3 times. So I go 25 times 3, that gives me 75. Now I like to subtract, but I'll do it differently. I know that 75 is 5 away from 80, so that's 5 I have to go up. And then I go 80 is 10 away from 90, so that's another 10. So I go up 5 to 80 and there 10 to 90, 10 and 5. That gives me 15 when I subtract 90 minus 75. I'm going to bring down the next value, which is a 3. Now I know for a fact that 75 does not go in 153 evenly, so I know I have to take this problem out a little further. The problem is I have no more digits to bring down, but I can add a decimal point. This is a whole number. At the end of every whole number here, we have a decimal point. Now I'm going to add, let's just say 2 zeros to the end. Okay, and I can bring these down whenever I need them. Now 25 times what will give me 153? Well, 25 times 4 is 100. 25 times 5 will be another 25 to 100, so 125. 25 times 6 will be another 25 to 125, so that's 150. That's pretty close. So that means 25 goes in 153 6 times. That will give me 150. I will now subtract, but I need to transfer this divisor, or this decimal into my divisor, so I'll put it up there. That's a 3. I bring down my 0. 25 goes into 30 one time. That gives me 25. I subtract, that is 5. Sorry, my handwriting here is getting slow, and that's 50. Well, we know 25 goes into 50 twice. So, my mean, or our mean, and let me change colors here, would be, or the mean for this set of data would be more appropriate, is 36 and 1200ths. I'm going to round that to, I'm just going to knock this 2 off, because if I underline the 2, underline the 1, because I want to round nearest 10th. Underline the 1 in the 10th place, circle the 2 in the hundredths. That 2 tells me just to leave the 1 as is. So we really have 36 and 1/10. Okay, so there is my mean. So I've calculated for my measure of spread, which was my range, which gave me 53. I've calculated for my median, which is, why do I have to calculate? I just have to put them in order from least to greatest. Found out my median was 31. Found out my mode was either 22, or both 22 and 28. I found my mean was 36 and 1/10. Now I have this word here called outliers. I always think of outliers as a word like outside. And outliers, sometimes they appear in a set of data by mistake. Maybe the person who's collecting the data made a mistake. Well, we didn't make any mistakes. These were the kids' test scores. Now, looking at these test scores, is there any number that looks extremely larger or smaller than the rest of the data in the data set? Because an outlier is that number that kind of sticks out. And if I look at this, I could almost say maybe I have 2 outliers. I have 63 and maybe 75. But that 75, since it's the greater one, I'll take that 75 as the outlier. Now you have to ask yourself, when I am doing the median, does the outlier affect what the median is? Will the outlier of 75, will that affect what the median is? And the answer is no, because when you're doing median, you're eliminating those outliers and just focusing as you get closer and closer to the middle. So the outliers do not affect the median. But when you're calculating for the mean, it does affect it, because you must add all the pieces of data that are in this set of data, or in the data set. So that's 75. You have to ask yourself, will that bring the mean up, making it larger? Or will it bring it down because it is smaller than a majority, or if not all, the data? Well, I would hope you understand that that outlier brings this data up, because it is much larger than the rest of the data, so it is bringing the data up. So it makes the mean a little skewed, meaning a little off, because it brings the overall average up. So if I were to ask you which measure of central tendency, the mean or the median or the mode, and usually when we're talking about measure of central tendency, we're focusing on the mean and median, not necessarily the mode. Which one, the mean or median, is the best representation for this set of data? And we'd have to go with the median. The reason being, this outlier affects the mean, making it a bit off, a bit skewed. So we're going to go with the median is the best number to represent this set of data. I hope this helps you. Take care.